So, if you're sick and tired of manually checking for environment updates before running your builds, you are absolutely in the right place. Welcome to this explainer. Today, we're taking a highly specific, but honestly, an incredibly powerful developer automation challenge and just breaking it wide open. We're going to bridge Dynamics 365 Business Central, Application Insights, and Azure DevOps to solve a very real-world problem. Now, this entire workflow design, it's based on a fantastic expert tutorial by Stefano Demiliani. And by the end of this, we're going to make your DevOps pipelines react to real-world infrastructure events instead of just your standard code commits.
All right, let's take a quick look at our roadmap for today. We've got 5 sections lined up: the Developers Automation Challenge, the Logic Apps Solution, Querying Application Insights, Passing Pipeline Parameters, and finally, Environment Lifecycle Signals. Let's jump in.
Okay, Section 1. The Developers Automation Challenge, Rethinking Pipeline Triggers. So a partner sent Stefano Demiliani this exact question. How do we automatically trigger an Azure DevOps pipeline when a Dynamics 365 Business Central environment update occurs? And, think about why this is currently such a huge headache for developers managing Business Central updates. Normally, developers have to sit around manually checking tenant statuses, or they're waiting on these delayed email notifications before they can safely push dependent code. It's frustrating. They were looking for a seamless, automated way to track when a software-as-a-service tenant actually received a successful update and then instantly kick off a downstream process based on that specific event, basically eliminating that manual bottleneck entirely. The contrast here is super fascinating. Think about your standard pipeline trigger. Usually, in Azure DevOps, pipelines are triggered when a pull request happens in a specific branch. Someone merges code, and boom, the pipeline runs. We are all highly accustomed to that workflow. But now, we're looking at a custom trigger based on a Dynamics 365 Business Central environment update. We are literally moving away from standard code-based triggers, and instead, we're actively listening for SaaS infrastructure events. It's a completely different, way more operational mindset for your automation. Moving right along to Section 2, the Logic Apps Solution, Building the Bridge. To actually build this bridge, we're leveraging Azure Logic Apps. Honestly, it's the perfect orchestration tool for this. And it really comes down to a very elegant 3-step workflow using the Application Insights and Azure DevOps connectors. Step 1. We kick things off with a timer trigger. Rather than trying to hack together a complex webhook, we just set the Logic app to run predictably. Now, quick pro tip here. A really common pitfall is setting that timer interval way too high, like every 5 minutes. That will quickly lead to unnecessary API calls and rate throttling. The fix? Just use a daily or twice daily check that aligns with your typical update windows. Step 2. We use the Application Insights connector to run an analytics query against our telemetry. And Step 3, based on those results, we use the Azure DevOps connector to physically queue up a new build.
Section 3. Querying Application Insights, Extracting the Signal.
Inside the Logic app, we use the Run Analytics Query action. We're executing a specific Kusto Query Language, or KQL, command right against the Business Central telemetry stored in Application Insights. To set this up correctly, your KQL query needs to specifically target the traces table. From there, you're going to filter for your specific environment name and the exact event ID that corresponds to a successful upgrade. You're basically digging into the system's log data and asking, hey, did this specific environment actually complete an upgrade today? And here is the absolute crucial point. It's this simple logical test. After our KQL query runs, it spits out a value. If that returned count is greater than 0, we know for a fact that the environment upgrade executed successfully. That count greater than 0 is our green light to trigger the pipeline. But watch out for this major pitfall. You absolutely must ensure your KQL query is restricted to a 24-hour time bin. If you forget to filter by the current day, your Logic app might just start accidentally triggering builds nonstop based on historical updates from weeks ago. Definitely don't want that.
Next up, Section 4, Passing Pipeline Parameters, Dynamically Feeding DevOps.
So once our green light condition is met, we don't just want to blindly trigger the build. We need to send it context so the pipeline knows exactly what it's dealing with. Using the QNewBuild action in the Azure DevOps connector, we send parameters using a JSON dictionary. You need to use the standard key-value pairing syntax required here. Now, when passing these pipeline parameters, a super common pitfall is malformed JSON. Seriously, missing a simple quotation mark around your strings or a comma between pairs is the #1 reason this DevOps connector action fails. Always validate your JSON syntax first. Inside your actual Azure DevOps pipeline, you capture those incoming JSON keys using this precise YAML syntax. $, double curly braces, parameters, .keyname. Now, Stefano's tutorial highlights a huge pitfall here that will instantly crash your pipeline, and that's forgetting to provide default values. The fix is incredibly simple, but it's totally mandatory. You always have to define these incoming parameters at the very top of your YAML file and assign them a fallback default value. When it's formatted correctly, your build just dynamically ingests that Logic App data without a single hitch. To give you a practical example of why this is just so valuable, you aren't limited to only passing static data. You can actually use a secondary KQL query in your Logic app designed specifically to grab the new destination version of your freshly updated environment. You literally take the output of that query and pass that exact destination version string right into your pipeline as a JSON parameter. This is a real magic moment in automation, guys. Your systems are talking directly to each other, and your pipeline dynamically knows the precise version number it's operating against, entirely without any human intervention.
All right, bringing it home with Section 5, Environment Lifecycle Signals, your automation cheat sheet.
While our explainer today focused heavily on success signals, Dynamics 365 Business Central actually broadcasts this entire suite of lifecycle events right into application insights. You get LC0100 when an update is merely available, LC0101 when it's scheduled. You can track missed, postponed, resumed, or started updates, and critically, LC0107 for a failed update. Just think about the developer process here. Instead of waiting around for a customer to complain that an environment is broken, a developer could use that LC0107 failure signal to automatically trigger an incident ticket in Jira or Azure boards instantly. That is a total game changer. So, you now know exactly how to automate builds, log work items, and instantly alert your team using these rich telemetry signals. The real question is, what workflow will you orchestrate next? Go experiment with your KQL queries, map out those JSON parameters, and start building smarter, more resilient infrastructure today.